Hello everyone, welcome to our channel Dynamic Cracker, and today we are in Trigonometry 06 class. In this class we will be deriving trigonometric identities. For class 10 we have only 3 identities and we will derive it super easily, okay? So let's start the class. So before deriving, you should know one thing. Do you know Pythagoras theorem? Yes, you should know that thing only. So what does Pythagoras theorem state? It states as AC square is equal to AB square plus BC square, right? And in a right angle triangle, what is a triangle? It should be CAB. This is some angle theta. So AB square plus BC square is equal to AC square. Alright. Now from this only we are deriving all 3 identities. Yes, it's very super cool. And here, before knowing that, I think you remember that if we have RHS and LHS, we can add anything to both sides. Same, we can subtract anything, we can multiply anything to both the sides, or we can divide anything to both the sides. You can do anything, but we should do for both the sides to remain this equality. Okay, so now let's divide. In this case, let's divide with some length. Now we have 3 AC, AB and BC, and from these 3 let's choose one thing and next let's derive. So what do you want from these 3 first? Let's choose Pinky Pinky Ponky. So let's choose AC, okay? So first let's divide the whole thing with AC, but as you can see everywhere there is square, AC square, AB square, BC square. So I want to divide with AC square, with LHS, for LHS also, for RHS also, okay? So if you divide, what becomes? AC square, here also AC square divided, and this is AB square plus BC square divided by AC square. All right. So now if you see here, this is nothing but you can write like AB square by AC square plus BC square by AC square. Can I write like that? Means just taking this as one thing and this one as one term, but if you add same, but if you add the thing, we get the same thing here again. So just I wrote it like that. That is nothing but AB square plus BC square by AC square only. So now you observe here, this is AC square by AC square, it gets cancelled, will be remained with 1. Okay, and if you come to here, this is AB by AC, you can write it as whole square plus BC by AC, you can write it as whole square. So just observe this. What is this AB by AC? If you take this angle theta into consideration in this triangle, AB by AC, opposite side for angle theta is AB and hypotenuse is AC. So opposite side by, we are making, just see, this is opposite side and this is hypotenuse. We are making opposite side by hypotenuse. What is this? This is nothing but sine theta. For that we are writing sine theta, that is sine theta whole square, plus we got AB by AC as AB by AC is sine theta. We didn't get, we know that. So next BC by AC. If this is sine theta and here we just took BC and that is adjacent side. So what will that become? So this is BC by AC and that is cos theta. Alright. So cos theta whole square. Okay, cos theta whole square. And as I said before, if you remember how we can write this thing, I'll just erase this. Yeah. Okay, right. Let me erase this thing. So this one will become 1 is equal to sine square theta plus cos square theta. That's it. This is one identity we call. One identity we got by dividing with AC. So when we divide with AC, we'll get one identity. So let's divide with BC also. Let's divide with AB also. Now let's choose BC. So for this, if you divide it by AC square, so BC square we are dividing. We'll take squares as we want. So if you divide it by AC square, BC square, AB square, because all are squares there. And here AB square by BC square, I'm writing it directly, BC square by BC square. You can see here BC square same gets cancelled out, get lost. And here if you see AC by BC whole square, this is AB by BC whole square, and this is 1. If you see what is this AC by BC, AC is hypotenuse, BC is adjacent side, hypotenuse by adjacent side, and that is secant theta, right? So secant theta whole square is equal to AB by BC, that is nothing but tan theta. So tan theta whole square plus 1, AB is opposite side, BC is adjacent side, opposite side by adjacent side, that is tan theta. Therefore this becomes secant square theta is equal to tan square theta plus 1. We got another identity. Okay, now we got even this also done. Now let's divide with BC. Sorry, we did that only, right? BC. Now let's divide with AB square, or else it will fail. With AB square, so AC square by AB square is equal to AB square by AB square plus BC square by AB square. AB square gets cancelled, that will become 1. AC by AB whole square is equal to, this is 1 plus BC by AB whole square. So AC by AB, what is AC by AB? AC is hypotenuse, AB is opposite side with respect to angle theta. So this becomes, I consider here angle theta, but you can consider even this also, then also you'll get the same identities. Yes. So AC by AB is hypotenuse by opposite side, that becomes cosecant square theta. Cosecant theta whole square, that is 1 plus, and here BC by adjacent side by opposite side, and that becomes cot theta whole square. As its side, we can write this one as cosecant square theta is equal to 1 plus cot square theta. Boom. So done. We found this one also. And for class 10, you have only these 3 identities. Once let's write down those identities. What are those? So what is first one we found? Sin square theta plus cos square theta is equal to 1, right? And next, second we found secant square theta is equal to tan square theta plus 1. And third we found cosecant square theta is equal to 1 plus cot square theta. Super. We have 3 identities in total. And from these identities we can get so many, like how we found for Pythagoras theorem. When we have one line, we found so many, nearly some 6 lines we found with one value when we have 3 values in it. I mean with one formula when we have 3 terms in it. So now let's find here. So first let's consider this one only, the first identity. And what is this identity? This is sin square theta plus cos square theta is equal to 1. So now I want sin square theta. What is sin square theta? 1 minus cos square theta. Sending this one to this side, LHS to RHS. So if you want sin theta, what is sin theta? 1 minus cos square theta of whole square root, something. So this is one. And next, if you want cos square theta, so cos square theta is 1 minus sin square theta. If you want cos theta, this is 1 minus, cannot write like this, sin square theta whole square root. So from these things we can find these both. Very good. And now if you consider for second identity, what is the second identity? Come on, say me fast. Louder, louder. So that is tan square theta plus 1 is equal to secant square theta. So now we send this tan square theta to this side, so it becomes 1 is equal to secant square theta minus tan square theta. Am I right? Yes. So this is one we got. Very good. And note here, wait, here only we can get one more thing. Do you remember this formula? A square minus b square is equal to a plus b, a minus b in algebra, right? So a square minus b square is equal to a plus b into a minus b, and if you see here, this is a and this is b, assume like that. So you get a square minus b square, that is secant square theta minus tan square theta. So if you consider this one to be a and this one to be b, a square minus b square, we can write like this. So what does this become? Secant theta plus tan theta minus secant theta minus, sorry, this is into, not minus, tan theta. Super. And if you want secant theta plus tan theta is equal to 1 by secant theta minus tan theta, or if you want secant theta minus tan theta, that is 1 by secant theta plus tan theta. Here we have multiplication. If you send two LHS, it becomes division. So first I send this one, this we got for this, and next I send this one, next we got for this. So we have again some 3 other formulas here. Okay. Next, you know, one more formula. What does we get? What is tan square theta? You know, secant square theta we got, and for to get this, just if you make the square root and remove here square, we get secant theta, right? What is for tan square theta? So tan square theta is equal to, this time this one you send to RHS, sorry. So secant square theta minus 1, that is tan square theta, and if you want tan theta, it becomes secant theta minus secant square theta minus 1 square root. That's it. So what is third identity? That is cosecant square theta is equal to 1 plus cot square theta. If you want this thing only cosecant theta, you can write as whole square root of 1 plus cot square theta. And next, if you want cot square theta, that is cosecant square theta minus 1. And for this, if you want only cot theta, that is square root of cosecant square theta minus 1. You'll be amazed why you are finding these many formulas, because in exam or in board exam or any questions, they'll not ask directly from this first identity. They'll ask from these things because just to confuse you. But you know this identity, and you just, if you don't know these things, everything is lost. So actually in question there only we should derive these things, but it will be easier for us to solve. I'll derive here only. You just remember them and directly write this, what derivation formula we got, you get marks. No need to worry at all. So where we are, so here this, so here 3 formulas for one formula, and this one is same for what we did. So if you want one, that is cosecant square theta minus cot square theta. So this is again a square minus b square, a plus b into a minus b. So let's, 1 is equal to cosecant theta plus cot theta into cosecant theta minus cot theta. So if you want cosecant theta plus cot theta, that is 1 by cosecant theta minus cot theta. Or if you want cosecant theta minus cot theta, that is 1 by cosecant theta plus cot theta. If you observe, for the previous identity and for this, both are similar, and if you want plus, you should take the reciprocal of minus. If you want minus, you should take the reciprocal of plus. That's it. So we got more 4 formulas, 3. So like this, you can derive from one formula these many formulas. to get the different values of the terms of one identity. So that's it for this class. In next class we'll solve some sums based on these identities. Mostly it will be proving types. Now how we proved, they'll give this one and they say how do you prove this, just how we derived it, we should prove it like that. And based on this, because we proved this, now based on this we should prove other questions. We'll solve like that questions. It will be very interesting and they are very important. Okay, so please like the video, subscribe, and meet you in the next class. Thank you.